Hello, I'm Papia. Today, we are going to discuss the continuity of a composite function. And the composite function is h of x defined by f of g of x. So it's a composite function, composition of f and g, where f is 1 over x minus 6 and g is x squared plus 5. Now, in order to understand the continuity of the function, I suggest that we understand the function itself first, the function h. And since it's a composition of two functions, it's a good idea to draw a little picture to understand where we're picking this x and how we are composing these two to get the final output for h. So let's start with a little picture. So say this is the domain, okay? Now, you're finding out the value h of x. How do you get this value? So you start with x, you plug in h, and then you get an output, h of x, right? So and h is defined this way. So you start with x right here. So say this is the set that you are getting x from. So here you have x, okay? Now, the definition says you have to first compute g of x. So you take x and you use the function g. So this next set will contain, we'll take this x and map it to g of x. So this is the function g that's applied here. So x is taken to g of x. Now you have this value, g of x. Now what you do, you have to apply f to this value. So you will have another set here. And you are applying f to this value. Then where will f take this value? To f of g of x. That's exactly h of x. So how do you get h of x? You start with x and you map all the way to this final value. These two are the same. This is h of x. That's same as f of g of x. So here is h. So this is the picture for a composition of two functions. Okay. Now we want to discuss the continuity of h. That means we want to find all those values here so that h is continuous. Now notice that the values here in the domain is actually the domain for the function g, not for the function f. So be careful, right? Okay, so let's write down what we know or how we get the continuity. So notice that if g is continuous at some x equals c. So say there is some x equals c where g is continuous. Then we also need the fact that f has to be continuous at that particular value, g of c. And f is continuous at g of c. Okay, so one more time. At c, g is continuous. Then at g of c, f is continuous. Then this h will be continuous at that c. This will imply that h is continuous at that same x equals c. Okay, so this is the picture, okay? We have to find all those x values where g is continuous such that f will be continuous at g of c. Then h is continuous. So let's see now, go back to the expression for f and g and figure out where they are continuous separately. Okay, look at g first. If g is continuous at c, where is g continuous? Or maybe we should consider the other way around. Where is there any place where g is not continuous? Look at the expression for g. It's just a quadratic expression. There is no denominator, it's a polynomial. G is continuous everywhere. So note that G is continuous for all x. There's no place where G is not continuous. Okay, that's good. Now, where is f continuous or discontinuous? So look at the expression for f. You see there is a denominator, and if the denominator is 0, function is not continuous there. And there is a point, right, where x is equal to 6. So we see that f is continuous everywhere except that one point. For all x not equal to 6, right? Everywhere else, it's fine. Only place is not continuous is at 6. Using those two facts, we have to figure out what's happening to h. So let's think about it one more time. 6 is a value where something is happening, right? But where is this 6 lying? We're talking about f. Look at the picture. Here is f. We are saying f is not continuous at 6. So the 6 has to be in this box, right? And in this box means 6 has to be some g of x, right? That's where things are going wrong. So this is very important. You have to figure out where is g of x equals 6. So if g of some value, say c, is equal to 6, then what happens? F is not continuous there, right? F is not continuous at that g of c, which means h is not continuous at that c. Every other place, it's fine, right? Everywhere else, when x is not equal to 6, everything works fine. That one place is where h will not be continuous. So we have to just figure out when is g of c equals to 6. So let's do that. We want to solve for c when g of c is equal to 6. Well, g of x is given right here. Plug in c. You get c squared plus 5 is equal to 6, which means c squared is equal to 6 minus 5, 1, which means c is equal to plus or minus 1. Please understand one more time, c is coming from the first box. So if c is plus or minus 1, g of c becomes 6, which means f of g of c not continuous, which means h is not continuous. Every other place, everything is fine. So our final answer, h is continuous at all x not equal to plus and minus 1. So those are the two values in the domain of h where the function is not continuous. Again, because when you apply g, you get 6 and f is not continuous at 6. Thank you.